Okay, today we're going to start chapter 6 and we're going to talk about the law of sines. And what I want you to know right away is the only time you can ever use the law of sines is if you have two angles. This is very important. Make sure that you have two angles or you're not allowed to use the law of sines. So that's very important. There is an exception. The exception is if you have something called the ambiguous case, which we'll talk about later. And so as we get to that, I will talk about that. In the law of sines, what they say is that when you see two triangles that you're talking about, you can compare sides with angles. And I think that it's always best to talk about, when you're doing this, how you would set this up. And what I would like to tell you is, I kind of like to write my triangles in a certain way, so as I do this, I will kind of talk about how this works. What you'll notice is that you can set them up with the sides on the top and the sine of the angles on the bottom, or if you want, it doesn't really matter, you can put the sines on the top and the side lengths on the bottom. And we can do it either way. I usually put the sines on the top. I don't really know why. It's just something that I do, and that's the way I've always done it. It doesn't matter, you can do it the other way. So this is kind of what happens. So let's say I'm drawing a triangle with the information that you see here, and then I start labeling some stuff. So I draw my triangle, and let's just say, for example, I put angle A on the left, angle B at the top, and angle C at the bottom. That means that angle B was 20 degrees, angle C was 31 degrees, and little side B was 210 degrees, and the side is always across from the angle, so the side for angle B, which was 20 degrees, is 210. And now, because I know that inside of a triangle there are 180 degrees, I can subtract from 180, and I know that angle A is going to be 180 minus 31 minus 20, which gives me a grand total of 129 degrees. So I know that angle A over here is 129. So I found the angle. Now I have two sides left to find. Let's say that I want to find side C first. If I wanted to find side C, I could do the following. I could say that the sine of 20 degrees, which is the B angle, divided by 210, which is the side across from that, should be in the same ratio as the sine of 31 degrees. By the way, make sure your calculator is in degrees for this, compared to the side across from it, which is the C side. So I'm looking at sine of angle B over the side across from it should be equal to the sine of angle C over the side that's across from it. At this point in time, we just cross multiply and solve. So that means that I'm going to be multiplying these two numbers and then solving, or in other words, the way that I would write my answer is I would say that my C side is equal to 210 times the sine of 31 degrees, and then I divide by whatever's left over, which means I would divide by the sine of 20 degrees. And you might want to, in your calculator, include parentheses when you're doing this. So maybe do this all together in a parentheses and then divide by the sine of 20. And then that way, be sure to eliminate any errors. If I do this, you can try this on your calculator now. What you should find out is that you get 316.23 for the C side. And if I want to do this same kind of thing, but to find the last remaining side, which would be side A, of course, I could set it up the same way. So I could say, hey, the sine of 20 degrees over the side across from it should be the same relationship as the sine of 129 degrees divided by the side A, which is across from it. And then, as before, I'm going to be looking at the cross multiplying and dividing. So I multiply these two things and divide by what's left over. And when I do that, what I end up seeing is that I have 200 for the A. I will have 210 times the sine of 129 degrees divided by the sine of 20 degrees. When you do this, you should find out that your A is 477.17. And what I've done is I found all the different pieces pertaining to this triangle. I found the other remaining angle and the two remaining sides. In number 2, same kind of problem. I'm just going to rewrite it again. So I draw my triangle. So here's my triangle. And in this triangle, I see that they give me two angles, so I can use the law of sines. Let's say I label it the same way, A, B, and C. That means that angle A is 48 degrees. I have angle B is 22 degrees, and little a is 5. So I can find again the remaining angle, angle C, which will be 180 minus 48 minus 22, for a grand total of 110 degrees, which means angle C is 110 degrees. So I've already found the remaining angle. If I want to find a side, like let's say for example side B, what I could do is I could set that up by saying the sine of 48 degrees over 5, which is the side across from it, is the same as the sine of 22 degrees divided by the side, which is B, which is across from it. Cross multiply and divide, so I multiply the two things that are diagonal from each other and then divide. And what that would give me is that B should be equal to 5 times the sine of 22 divided by the sine of 48. And these are all in degrees, so make sure your calculator is in degrees. This means that my side B should be 2.52. So check that on your calculators and make sure that you can get that. Remember, you can always pause this video at any time. And then if I want to do the last part of this particular problem, what I know is I could set it up in a similar manner. So if I set this up in a similar manner, I could do that the sine of 48 over 5 equals the sine of 110 all over side C. So these relationships are talking about the sine of a certain angle divided by the side across from it. It should be the sine of a different angle divided by the side across from it. And so now I cross multiply again and divide by what's left over. So I know that side C should be equal to 5 times the sine of 110 degrees divided by the sine of 48 degrees. Or in other words, when I find my final answer, C should be 6.32. Okay, in this next set of problems, I want to kind of talk about something kind of cool. What I want to talk about is just any general triangle. That's something we want to look at. And so let's say, just for example, which has nothing to do with looking up above for right now, but let's just say that I was looking at a particular example that looked like this. Let's say I had a triangle like this, had a height, looks like this, and let's say that I told you that the triangle had the sides 5, 6, and 7, and had an angle of 10 degrees, and I called this angle A, and that's all I told you, and of course this could be a B, I suppose, and this could be the C. And let's say I wanted to find the area of this triangle. And we always know that when we're talking about areas, the area of a triangle is equal to 1/2 the base times the height, or base times height divided by 2 if you like to write it that way. And here in the red vertical line, we see the height, but we don't know what it is. So I kind of want to figure that out. And so one of the things I could do is I can actually figure out that height if I wanted to. So let's say I label this thing h for the height, and I wanted to figure that out. Take a look at the left-hand side of this triangle over here. Or in other words, this part of the blue triangle. It is its own little separate triangle. And if I only look at that triangle in the green shaded area, if I'm looking at that triangle, the left side, what I can tell you is that I know that in that triangle, that the sine of 10 degrees is equal to the opposite side, which is h, over the hypotenuse, which is 5. And if I solve that for h, by multiplying both sides by 5, I would find h is equal to 5 times the sine of 10 degrees. So I found the red height that I was looking for. Whoopsie, sorry, let me undo that. And the reason I'm showing you this is because it pertains to the material that we're going to learn next, which is about something called the ambiguous case. So this height that I'm talking about is always the 5, which is the left side of the triangle times the sine of the left angle. That's my height. So let me just show you where these are coming from again. My height, which I'm calling h, is the left side, 5, times the sine of the left angle, 10. Maybe I should use a different color, sorry. I'll use brown. And that's how they're finding the height. Now the reason I'm telling you that is in the stuff that we're going to talk about next. What you'll see is that when we talk about the height, everything that we do here is in reference to the height. All three of those pieces are talking about height. So C, you'll see, is the left side, and the sine of A is the sine of the left angle when you set up your triangles. So as I do these problems, I'm going to mention certain things to do, and it's always referencing back to this thing about how we're using this height to determine certain things. Let's try a few problems. In number 3, what you'll see is that they give us certain information. And you are going to do something a certain way and always